Okay, thanks for joining me. We are going to talk more about Camera Fundamentals 3, and we are going to focus on lenses and optics. So let's get started. Okay, so a little bit about lenses. They're kind of complicated things on the front of our cameras, often with multiple ground pieces of glass that help create a image that's focused on the sensor or on the we call that generally the image plane. Yeah, so this cutaway version gives you a sense of everything going on. But let's go over a little bit of the anatomy of the lens. So the first thing that defines the lens really is its focal length or its focal length range. So that would be the image stabilized, like in this case, it's an image stabilized lens, but it's a 24 to 70 millimeter lens. And then this is what's considered a zoom lens, goes from wide angle to slightly telephoto. Another component of our lens is a focus ring. And when you twist that on the lens, that's going to change the relative focal distance that you're focused on, okay? Where are you focusing? Number 3 is a switch that's going to change between turning the autofocus motors on versus turning them off on manual. Most of the time that's on the lens. Sometimes on Nikons that is on the camera body itself. Then if you're lucky, your lens will have a distance scale built into it, so you can see when you move the focus ring, it will show you at what point you're focused on. And it's good to pay a little attention to this. You'll see some numbers here, 24, 35, and then the main white line. And those indicate slightly different focal points for different focal distances. 5 is the maximum aperture. This is one of the most, the other main thing that we define lenses by is the maximum aperture that the lens can open up to. And so you always see a number, which is a 1, a colon, and then another number. That second number, in this case, the 4, tells us what the f-stop is. So this has a maximum aperture of f4. Some lenses have image stabilizers built in, and you can turn those on and off, usually on the camera. And again, image stabilization does what you think it sounds like it's saying it does. So helps you take a picture and avoid camera shake at a slower shutter speed. The zoom ring is another important feature of a lens. If it is a zoom lens, it means that the focal distance can change. You can go from, let's say, a wide angle lens in this case to more of a telephoto focal length, right? So the zoom ring is going to control that. There's a indicator, a focal length selection indicator, and then the number will move along, and whatever number you're at, that's the focal length you have selected. So that's the basic overview of the lenses. Lenses are, as I said, described by 2 main things. That's the focal length and their maximum aperture opening. So in this case, this Canon lens, it's a 50 millimeter lens. It's always measured in millimeters. Rarely is focal length measured in inches. But here you see it's a 1:1.4. So the maximum aperture on this is f1.4, which is considerably bigger than the previous lens of f4. Almost 3 whole stops. So that means it'll let in almost 8 times as much light as the other lens, or it will actually precisely. So down here we have a Nikon lens, and it's a zoom lens, a 24 to 50 millimeter lens. And there's something interesting to make a point about here, which is below that you see these other numbers. That's the maximum aperture, but there's a dash. And what is that? Well, when it's, remember, the 1, the colon, doesn't really mean anything except to tell you what comes after that is the maximum aperture. So this says 3.3-4.5. That means at 24 millimeters, it's going to have an maximum aperture of 3.3, but when you zoom into 50 millimeters, that maximum aperture decreases a bit and goes down to 4.5. So that's how that works. There are 3 main categories of lenses. This is normally the way we think of them. We think of a normal lens, a wide angle lens, and a telephoto. A normal focal length lens means the one that most mimics how our eyes see. Now, for a full frame DSLR camera, that would be a 50 millimeter lens. But for some of the cropped sensor sizes, the DX or the APS-C sized sensor, it's about 2/3 the size of the lens, sorry, the size of the full frame sensor. And those are um, a normal focal length would be 35 millimeters focal length. Yeah. So some other things that we need to think about when we're thinking about lenses is that both wide angle and telephoto lenses distort the image. The more extreme the focal length, the more noticeable this distortion. So this image up here is of a wide angle lens, and you can see one of the things immediately recognizable is how these poles are bowed on the sides, right? And we know just from our sense of reality that that's not actually the way things look to our eye if we were on the scene. That's a distortion of the camera. And because of the extremely wide angle that happens, it's called barrel distortion. Um, but one of the things the wide angle lenses do is they accentuate a sense of depth. Remember that in photography, we're photographing three-dimensional spaces, real spaces, but we're projecting them onto a two-dimensional plane. So there's a certain amount of flattening that happens by that very nature. Wide angle lenses, though, are better at depicting recession of space, right? Which is really kind of what depth or a sense of depth in a picture means. Now, telephoto lenses decrease that depth. They do the opposite, and they make an image appear more flat or 2D than a normal lens, like a 50 millimeter lens. And you can really see that here with this bear. You've got a bear and you have a kind of big boulder here. If I was testing you like, well, is that boulder in front of the bear? Is it behind the bear? Is it alongside the bear? It's almost impossible to tell. And that gives you a sense of how that um, space is being flattened by a telephoto. So here's another example of a wide angle lens on the left being taken of this cross memorial, and then one on the right being taken with a telephoto of the same cross. You can really see there's the distinction between the two. Now, the person that took this picture was didn't photograph from the same position. They had to move around to get the same relative size of the cross in the frame. But boy, you can tell a difference between how the background changes in relationship to the size of the main subject, in this case, the cross, between the two. So notice how far away the cityscape feels in the wide angle lens compared to the cross, but in the telephoto lens, things seem much closer together. That background doesn't seem nearly as far away, and it's much larger in relationship. So these are important things to think about. Here's an example of a fisheye lens, which is an extreme wide angle lens, and so you get extreme distortion. Often these lenses can take in a field of view from 180 degrees or more, right? So that's if you were looking south and then you were looking north, you could get that entire view between those two all in one frame, which is pretty impressive. Thanks for joining us, and check out the next video on optics.